Hello, my name is Santiago Mol Lopez, and in this video we will learn how to calculate the derivative of a product of functions and also compute the derivatives of quotient functions. The prerequisites for this video include a familiarity with the derivatives of elementary functions. However, even if you're not well versed in them, we will cover the most important ones during this presentation. Let's start with the product rule. What does it consist of? Imagine that we have a function that is the product of two functions. In this case, g of x and h of x. How are these functions differentiated? The product rule states the following. The derivative would be this way. At first it seems a little difficult, but we are going to try to understand what it consists of and how it applies. What you need to focus on initially is differentiating the function g of x while leaving the second function undifferentiated. As you can observe, the first part of the product rule involves taking the derivative of the first function and leaving the second function as it is. Now, we add the product of the first function, the one we initially left undifferentiated, and the derivative of the second function. It's not overly complex, but it's crucial to apply it correctly. It can be tempting in exercises involving the product of two functions to simply differentiate one function and then the other and add them. However, this approach would be incorrect. The derivative of a product must be calculated using the product rule. Let's illustrate this with an example to delve further into the topic. In this case, we have a function that is a product of two functions. One function is x, and the other function is the sine of x. In this case, if we break it down, the function x would correspond to g of f, and the function h would be the sine of x. How do we differentiate this product? Let's start. The derivative of the product would be the derivative of the first function, which is the derivative of x, and you should recall that it is 1. Therefore, it's 1 times the second function without differentiating, which is why you see 1 times sine of x. Now, add the first function without differentiating, which is x, multiplied by the derivative of the second function. You must all remember that the derivative of the sine is the cosine. I will be left with the following expression, sine of x plus cosine of x. Let's see another example. Imagine that now we take the function e raised to the power of x and the arctangent of x. Although it sounds complicated, in principle, the only thing I need here is its derivative. So, how do we differentiate this product? As before, by applying that same rule, we would have the derivative of e raised to the power of x, and it's important to remember that the derivative of this function remains the same, multiplied by the arctangent of x without differentiation. This represents the derivative of the first function by the second function without differentiation. Additionally, you add the first function without differentiation, which is e raised to the power of x, multiplied by the derivative of the second function. The derivative of the arctangent of x was 1 over 1 plus x squared. When finding the derivative of a product, apply this rule even if the expressions seem complex. Here we've examined it step by step, but in the end, what remains is e raised to the power of x times the arctangent of x. All I've done here is multiply e raised to the power of x by the fraction raised to x in the numerator. Now, let's delve into the quotient rule, which is quite similar to the product rule but has some important distinctions, such as the fact that it ultimately results in a quotient. Here's the rule. At first glance, it may seem complex, but it's not. You have a function, which is the quotient of two functions. In this case, g of x divided by h of x. How is it differentiated? It's actually quite easy. We differentiate the numerator, as you can see here, and then we multiply it by the denominator without differentiating. Now, be careful with the subtraction sign, as it's a common source of mistakes. Subtract the numerator without differentiation by the derivative of the denominator, and then divide the result by the squared denominator. Let's examine some examples. Earlier, we had the expression x times sine of x. Now let's calculate x over sine of x. We can apply the same derivatives we've used before. The derivative of x is 1, and the derivative of sine is cosine. Let's start. In this case, the derivative would be like this. Let's go step by step. First, we differentiate the numerator. The derivative of x is 1. Then, we multiply it by the denominator without differentiation. Next, subtract the numerator without differentiation, and multiply it by the derivative of the denominator, which in this case is the derivative of sine of x. Lastly, divide the whole expression by the denominator squared. If we simplify this expression, it would indeed become sine of x minus cosine of x divided by squared sine of x. What we've done here is simply remove the 1. Also, we have placed the exponent of sine of x right beside it. This notation is often preferred because it helps avoid confusion, especially when calculating sine of x squared. Placing the exponent closer to sine indicates that the entire sine function is squared. Let's examine another example. The tangent of x. You may have thought that it is not a quotient of functions, but in fact it can be viewed as such. By definition, The tangent of x is equal to the sine of x divided by the cosine of x. And here we have the opportunity to deduce the derivative of the tangent of x. How is a quotient differentiated? With this rule. Let's apply it. The derivative of the sine divided by the cosine would be this expression. Let's go step by step. If we follow the rule, it involves differentiating the numerator, sine of x, which becomes cosine of x, multiplying it by the denominator without differentiation, subtracting the denominator without differentiating, and then multiplying it by the derivative of the denominator, which is the derivative of cosine. This gives minus sine. This entire expression is then divided by the square denominator. Let's simplify this expression a little because it is quite interesting and we can review some trigonometric formula. When you multiply cosine by cosine, you get cosine squared. And when you multiply minus sine by minus sine, the double negative turns into a positive, resulting in sine squared, as you can see in the following expression. Now we have two ways to finish this simplification. First and foremost, I'd like to remind you of a fundamental trigonometric identity. The cosine squared of x plus the sine squared of x is always equal to 1. If you recall that identity and simplify it, you can express it as 1 divided by cosine squared of x. I insist, this numerator is always equal to 1. It is a very important trigonometric formula. Another way to complete this simplification, considering it as a quotient, is to separate the fraction into two parts. One part would have cosine squared of x divided by cosine squared of x, and the other part would have sine squared of x divided by cosine squared of x. The first fraction, cosine squared of x divided by cosine squared of x, is 1, because the numerator and denominator are the same. And the second would be sine squared over cosine squared. If the tangent is sine over cosine, the sine squared over cosine squared will be tangent squared. Thus both expressions could be simplified like this. Both expressions are equivalent, therefore you could use any of the two when you need the derivative of the tangent of x. A note about the product rule. What happens if instead of two functions multiplying each other, we have three? This result can be generalized in the following way. The derivative would follow this pattern. The derivative of the first function multiplied by the second and third without differentiation, plus the first one without differentiation, multiplied by the derivative of the second and multiplied by the third one without differentiating, plus the first and second without differentiating multiplied by the derivative of the third. This method involves differentiating one of the three functions while leaving the other two as they are, and then adding these three components together. What have we seen today? Today we have reviewed the product rule and the derivative of the product of functions. We have seen how it works, we have seen some examples, and we have done the same with the quotient rule. I hope it helps you.